Good afternoon everyone, hi there and welcome to another video from Hegarty Maths. It's Mr Hegarty here and we're continuing with our YouTube live lessons. Now I hope you guys had an okay weekend. A lot of the days merge into one during lockdown and it's difficult to tell the difference. But one of the differences is that we have the YouTube live Hegarty Maths lessons on the weekdays. So just a reminder of what these all are about. What we're doing is we're doing a little bit of practice each day on topics that are the higher end of GCSE and bridge you across to A-level. These are for students who are thinking of doing A-level and just to keep fresh while schools are on lockdown, just to make sure we do something positive with our days. So big shout out to everyone. Thank you so much for joining this session. Say hello on the chat and I really appreciate you joining today because it's something positive we're doing together and we're really proud of it. And remember, we are what we repeatedly do. Excellence is not an act but an habit. These little and often bits of good practice every day, they can help us become really good at maths and they're a good positive thing to do. So hi there guys, hi. So what are we doing? So today we're going to continue and finish off our last lesson on surds. And we are going to be rationalizing fractions where there is a surd on the denominator. As always, I need your brain. Your brain has to be fully alert today to make sure we cover some of the material. I'm going to make it a bit more difficult in this particular session. Remember, write stuff down, guys. Absolutely must write stuff down. The point of this session isn't to just get answers or tap it into the calculator or Google the answers. It's to have a really precise, good way of doing our working. So every time I do an example, you copy, and then I'll always give your turn where you should write it down. And we can do this, guys. So let's kick off, and we're going to start where we left off last time. Do you remember in the last lesson, I talked about situations like this? And I said, we never like a surd on the denominator. So what we do to get rid of that surd is we would multiply this fraction by root 5 on top and root 5 on bottom. This would give us 7 root 5 on the top, and root 5 times root 5 just gives me 5. Okay, and effectively we have made that difficult surd go on the numerator as opposed to the denominator. Now what we're doing in this lesson is very similar. We're trying to deal with fractions like this, where there is a surd on the denominator. So we've got 7 divided by 2 plus root 5. Now some of you might be thinking, so why don't we just multiply this by root 5 on top and root 5 on bottom? Won't that just get rid of that nasty surd on the denominator and help us through this? Well, if we did that, what would we get on top? 7 root 5. And on bottom, what we've got is root 5 multiplied by this bracket. So it'd be root 5 times 2, which is 2 root 5, and root 5 times root 5, which is 5. Now this hasn't helped us, guys, because we've still got another root 5 on the bottom here. And so we're not in a particularly better situation. Now, we covered this in lesson 2. What we're going to actually multiply the top and bottom by, we have the bottom in the form a plus b, right? A is 2 and b is equal to root 5. If we multiply the top and bottom by a subtract b, or 2 subtract root 5 and 2 subtract root 5, on the top we would get 7, 2 subtract root 5, but on the bottom, a plus b multiplied by a subtract b is always a squared take away b squared. It's called the difference of two squares. We talked about this in lesson 2. And on the bottom, therefore, this gives us 2 squared take away root 5 squared. And actually, if we follow that through, 2 squared is 4 and root 5 squared is 5. So we've got 4 take away 5, which is negative 1, and that gets rid of this surd on the bottom. So in this particular lesson, what we're going to do is dealing with cases like this. I'll show you a full-blown way of writing it out really neatly, but just to show you, we're always going to use this method. If we've got a plus root 5, we're going to multiply it by a subtract root 5. So let's have a go at our first example. Remember, a lot of the stuff we're doing here on Hegarty Maths is about how to write it down. It's not about racing to the answer. So we're asked to rationalize the following and give our answer in the form a plus b root 3. So in order to do that, we're going to say we're trying to rationalize 4 over 1 plus root 3. And showing our working neatly, what do we multiply the top and bottom by? Well, we've got it in the form, this bottom here is of the form a plus b, where a is 1 and b is root 3. We're going to want to multiply it by a subtract b. So we multiply the top and bottom by 1 subtract root 3 over 1 subtract root 3. And hopefully you'll see this will eliminate the surd on the bottom. So on top, what do we get? We've got 4 brackets 1 subtract root 3 over a plus b multiplied by a minus b. The answer to this is always a squared take away b squared. So 1 squared take away root 3 squared. So let's just expand the top. 4 multiplied by 1 is 4. 4 multiplied by negative root 3 is negative 4 root 3. All divided by 1 squared is 1. Take away root 3 squared, which is 3. So we've got 4 take away 4 root 3 all over negative 2. And we're nearly there, guys, because what we can do is we can do 4 divided by negative 2 is negative 2. And negative 4 divided by negative 2 is positive 2. So we've got positive 2 root 3 here. So we have our answer in the form required. We wanted it in the form a plus b root 3. We have that where a is negative 2 and b is equal to positive 2. And we're done. So hopefully you can see this is a lot more tricky than what we did last lesson. There's a lot more lines of working. All of this is about showing you're working neatly and not just getting to the final answer super fast. So, as always, you guys have a go. Here you go. I will be quiet for a minute and rationalize the following, leaving your answer in the form a plus b root 7. Type a and b into the chat. Wow, so we're getting some really good answers over there in the chat. Well done, guys. Remember, as always, okay, if it's going a little bit fast for you, this video is recorded. You can re-watch it, and I'm going to post the notes after so you could redo all the questions anyway. But a lot of you are saying that A was equal to negative 3 and B was equal to 3. Let's have a look. That's exactly what I got as well. I got A was negative 3 and B was positive 3. And the final answer, some of you are even typing that into the chat with square root symbols. Well done, people. Is negative 3 plus 3 root 7. Well done, people. Right, let's have a go. Another one. A similar one, but maybe a slightly more difficult. And it's going to get more difficult as we go along. So next one here. Rationalize the following, leaving your answer in the form a plus b root 2. So we're trying to rationalize 2 divided by 3 subtract root 2. Now, is there anything different in this example? Well, not really. We've just got the denominator in the form a subtract b. So remember, to get a squared take away b squared, we're going to multiply it by a plus b. So what we need to do is we've got 3 subtract root 2 on the denominator. We're going to multiply the top and bottom by 3 plus root 2. And follow our noses. Keep going. So on the top, that's just 2 bracket 3 plus root 2. Happy days. And on the bottom, we've got a take away b multiplied by a plus b. That's just going to be a squared take away b squared, or 3 squared take away root 2 all squared. On the top, we can expand. 2 times 3 is 6. 2 times root 2 is plus 2 root 2. And on the denominator, what have we got ourselves? We've got ourselves 3 squared is 9, take away root 2 squared, which is just 2. So tidying this up, we've got 6 plus 2 root 2 all over 7. Now you guys might say, well there sir, we've got it. Remember the question asked us in this form, a plus b root 2, and state a and b. So just to tidy up the last little bit, we've just got to divide that 6 by 7 and got 6 sevenths plus 2 root 7 over 7. We can write that as 2 sevenths root 2 like that. And it's in the form required where a is equal to 6 sevenths and b is equal to 2 sevenths. Sometimes that last little bit catches people out when they're not whole numbers. Don't stress out, guys. Don't even try and decimalize this. Leave this as 6 sevenths and 2 sevenths and it's absolutely fine. So, it's over to you guys now. Very similar idea. Be careful with your fractions at the end. See if you can get a and b here. Again, a bit more tricky than first example. Here you go. We got Asmol here with an answer, probably first to answer. Wow, we've got Claire there with an answer, Nathan, Khadija. Wow. Azosa. Wow, some people are coming through with answers. I'll give it another few seconds. So let's just have a look at the answer here. We got a lot of people writing in there. A was 8 over 11 and B was 2 over 11. Let's see if I got the same thing. Let's reveal all the lines of working. And indeed I did. A was 8 divided by 11 or 8 elevenths and B was 2 elevenths. So well done everyone, well done. That was a tricky one, especially with the fractions at the end. Okay? Really good job there, people. Remember, if you didn't have enough time, it's okay. Watch the video afterward with the notes and you'll be able to do it at your own pace. It's not a rush. I'm just trying to do it in a way that makes sense for as many as possible. But well done, people who got that. That was tricky. Okay, next question. We're doing 2 more today. So next one's a little bit more difficult again. Here's the next question. Rationalize the following, giving your answer in the form a plus b root 5. So, just before we get going, we've got 12 over negative 1 plus root 5. When I see the negative first, I would just like to write that in this form. I like to write the positive root 5 first, then take away 1. They're equivalent to each other, and this just helps me with my arithmetic just to make things a little easier. So that was a little trick to get us going. Once you have got going and we're trying to rationalize the following, we just follow our nose and do what we've been doing all the way along. We've got it in the form a take away b on the denominator. To rationalize that, we're multiplying it by a plus b, or multiplying top and bottom by root 5 plus 1. As follows. Expand the top. you've got 12 bracket root 5 plus 1. And on the bottom, a take away b multiplied by a plus b, difference is 2 squares, a squared take away b squared. So that's going to be root 5 squared take away 1 squared. Expand the top, 12 root 5 plus 12, over the denominator, which would be 5 take away 1. That's 12 root 5 plus 12 over 4. And so we get 12 divided by 4 is 3 root 5. And here's 12 divided by 4 again, so it's plus 3. Now be very careful here, people. This is very important. We asked in the form a plus b root 5. Okay, so let's just rewrite this as 3 plus 3 root 5 there in the right form, where the number is first and the surd is second. So therefore, we've got that a in this particular case is 3 and b is also 3, and we're done. So the little bit of trick in this one was the rewrite at the start, and just at the end be careful to write it in the form a plus b root 5, not b root 5 plus a, just in case those numbers are different. Okay, over to you. Here's one for you. We'll work in the exact same way. Have a go at this one, please. Well done, Malia, Khadija, David, Asmol, Nathan, Sam, Parry, Edward. Some really good work there from people. So just to reveal this answer, what did I get? Well, I got in this particular case that A was equal to 30 and B was equal to 10. So someone put A is 10 and B was 30. Just remember, guys, the A was the number term, the B was the number in front of the surd. So just be careful of that. That's why I said that little trick there. Just be careful at the end to get your answer in the right form. But well done. It's all right. Some people, it's all right, Harry, got it backwards. That's absolutely fine. You did the really difficult part. Just at the end, just be mindful of that little bit there. That will be the last mark. Okay, the last question. Now, just to warn you, the last question today I've seen as an exam standard question. So be careful and follow along with me. It's a little bit tricky. It's not as easy as some of the others today. So we're just going to do the last one carefully and then we'll be done. So, a rectangle has area 2 plus root 2 centimeters squared and a width of 3 root 2 take away 4 centimeters. We are asked to find the length, give our answer in the form a plus b root 2. Okay, so there's a lot going on here. So the first thing I ever do when I get a question like this is I'll draw a little picture, just to see if I can actually translate what's in the text into sense. So what we're told is that the area is 2 plus root 2 centimeters squared. We're also told the width is 3 root 2 take away 4. So 3 root 2 take away 4 centimeters there. And we're asked the length. Because we don't know the length, let's just call it x, right? So this length here, let's call it x centimeters, and we're trying to find it out. Now, what we do know for a rectangle is that the length times the width would give us the area. So let's just state that. We could say that x multiplied by 3 root 2 take away 4 has got to be equal to the area 2 plus root 2. Okay, that's got to be true. So therefore, what we can say is if we're trying to find x, if we divide both sides by 3 root 2 take away 4, we would get that x must be equal to the answer 2 plus root 2 divided by 3 root 2 take away 4. Now, that is x, that's the length. However, the question asked us to put it in this form here. And we've got surds on the top and bottom, and we've got not in the form required. Now, we've got 3 root 2 take away 4 on the bottom. We need to rationalize the denominator. So keep that 2 plus root 2 there, and keep the 3 root 2 take away 4. We've got this in the form a take away b, where a is 3 root 2 and b is 4. So to rationalize that, multiply the numerator and denominator by 3 root 2 plus 4. Okay, so let's see if we can do that on the top. So what we've got on the top is we've got 2 plus root 2 multiplied by 3 root 2 add 4. And on the bottom, we've got a take away b multiplied by a plus b. So that's going to give us a squared take away b squared, difference of 2 squares, where a is 3 root 2 all squared, take away b squared, which would be 4 all squared. Now this is where we've got to be careful. I'm going to do some separate working here. 3 root 2 squared. I'm going to go over here and work that out just to make sure I'm not doing it in my head and making mistakes. 3 root 2 squared means 3 root 2 multiplied by 3 root 2. And if we take a step-by-step approach, 3 multiplied by 3, well, that's equal to 9. And the root 2 multiplied by the root 2 is going to give us 2. So we've got 9 multiplied by 2 here, which is equal to 18. So we've worked that out. That's 18. So let's continue. This is where it does get tricky because the top has double brackets. Remember on Friday when we expanded these, we said just write that as 2 multiplied by the second bracket plus root 2 multiplied by the second bracket. So I'm just going to do that to make my life easier. 2, 3 root 2 add 4 plus root 2, 3 root 2 add 4. And I'll come back and deal with that in a second. The denominator, 3 root 2 all squared is 18. Take away 4 squared, which will be take away 16. So, continuing going, 2 multiplied by 3 root 2 is 6 root 2. 2 multiplied by 4 is 8, so we've got plus 8. Plus root 2 multiplied by 3 root 2. The root 2 times the root 2 is just 2. So we've got 3 times 2, which is add 6. And root 2 multiplied by positive 4 is positive 4 root 2. All divided by 2. Now we're close here. What I'm going to do is I have to shift up some of this working because we're running out of space because we've done so much maths here. But keep going. So on the top, collecting like terms, we've got 6 root 2, add 4 root 2, and we've also got 8 add 6. So therefore, 8 add 6, writing the number term first, is 14, plus 6 root 2 add 4 root 2 is 10 root 2. And don't forget you've got your divide by 2. We need it in the form a plus b root 2, so divide both of these by 2. We would get ourselves 7 plus 5 root 2. And that there is our final answer, where a is equal to 7 and b is equal to 5. So that's a lot more tricky now, guys. There's a lot of workings here, a lot of places to go wrong. But this is the type of way it could come up, and this is the type of difficulty that you need to get good at. And it's okay. You could watch this after if you're not entirely sure how I'm doing it. I'm confident you guys can understand this. So I'm going to give you guys your own go. It is tricky. There is a lot of working, so I'm going to be quiet for quite a few minutes here to see if you guys can do this one. And then we'll call it a day. We'll wrap up and I'll tell you what to do next and we'll prepare for tomorrow. Here's the last question. Pause and see if you can work through and get an answer for A and B here. Asmol's in with an answer. Wow. Munira, Matt, Parry, Emily. Saba, Dua, Ali. Okay, so I'm going to reveal the answer. There's some answers coming through on the chat already. The answer I got was as follows, and here are all the workings. I got myself that A was equal to 3 and B was equal to 4, and the final answer was actually 3 plus 4 root 3. And loads of you on the chat seem to have got that, which I'm really, really impressed with. Now, a couple of things to say at the end of this session, a couple of important things. Some of these workings take time. If you were looking at the chat and saying, how did some of those people get the answers so quickly? Don't stress. Please go back and watch the video. Take your time and you can do it. Do not feel pressure. Maths is not about speed and pace. Maths is about showing your workings, being careful and doing the best you can. Sometimes I get stuff wrong. Many times in life, I take way longer to understand things than other people. So please don't worry if that's you. I've got confidence in you. What do I recommend you do next? Well, what I recommend is I'm going to post underneath the video the links to today's lesson. Go back over them. Do all the your turn section and my turn section in about an hour's or so time, just to make sure it's stuck in that brain and you can do it without my support and you can do it without the distraction of the chat and stuff like that. And then I've got a little review exercise for you to have a go at some questions, and the answers will be provided in the PDF. So I want to say massive shout out today, guys. Please like this video. Please share it with your other friends in year 11 who might need a little bit of support. It really helps this spread and help as many people as possible. So do like it before you go. I hope it's useful. And for the rest of the week, we're going to start doing indices. And we're doing all the indices and index notation you guys might need as an introduction to A-level maths. So well done, guys. Really proud of you. Thanks so much for your support, and make sure you like that video before you go and share it around so as many students can benefit as possible. Take care, guys. Have a lovely day. Cheers. Bye.